This is question 139 from your trig packet. This question is a little bit more in-depth than the last few. It's going to require to use a couple of trig. Well, it's going to require to use the sum and difference formula, and it's going to require to use a double angle formula. So let's go through, and we start it the same way, and we say that sine inverse 15 over 17 is really just theta. So theta equals sine inverse of 15 over 17. Which means if I take the sine of each side, that's really just sine theta equals 15 over 17. Which means I can draw a triangle, label this angle theta, and if sine is 15 over 17, then that means the opposite side is 15, the hypotenuse is 17. I'm going to use the Pythagorean Theorem, so I have 17 squared minus 15 squared equals a squared. So I'll take the square root basically of 17 squared minus 15 squared, and that'll be what this a piece is right here. Plug that in the calculator. 17 squared minus 15 squared, 8. So this is 8 right here. So then I can say that cosine theta is equal to 8 over 17. I don't really need tan for this problem, but let's write it anyways. This is 15 over 8 for tan theta opposite over the adjacent. So we'll start down the left side and we'll say that cosine of 3 sine inverse is really just cosine 3 theta because of the substitution that I used. Which means that that's really just cosine of 2 theta plus theta. Well, this is a sum formula for cosine, 2 theta plus theta, so I've got double the angle plus theta. I'm going to go ahead and use the cosine addition formula, which would mean that this is equal to cosine 2 theta cosine theta minus sine of 2 theta sine theta when I plug in those angles into the formula. Well, I know what cosine 2 theta is. I can now substitute in this double angle formula that we're looking at here, cosine 2 theta. I'll use the middle one, so I'm going to say that that is really just 2 cosine squared theta minus 1, replacing this cosine 2 theta, and then I have cosine theta being multiplied times those two things. Then I'm going to replace sine 2 theta with its double angle formula, which would be minus 2 sine theta cosine theta. That's the double angle formula for sine 2 theta. And then I have this times sine theta at the end. So I'm at a good spot now where I can actually do some substitution of the ratios that we have. All I have to do is plug in 8 over 17 for anywhere I see cosine theta, and then plug in 15 over 17 for anywhere I see sine theta. So I start writing this. This is 2 times, this would be 8 over 17 squared minus 1 times 8 over 17. And then I have minus 2 times sine theta, which is 15 over 17, times cosine theta, which is 8 over 17, times sine theta one more time, which is 15 over 17. Now I can actually use my calculator to do all the work if I want. So I'm going to plug this in. And let's just add in all the parentheses. So I have 2 parentheses using the fraction button is going to be advantageous to you. Then minus, I'm going to put all these in parentheses, so just 2 times this fraction, which is 15 over 17, times and one more time with the fraction button. Double check that it's correct. Looks good to me. So we get negative 4,888 over 4,913, which means that cosine of 3 sine inverse 15 over 17, when it's evaluated, gives you negative 4,888 over 4,913. Now what's important about this is still greater than -1. It's close to -1, but it's greater than -1. This tells you if cosine's close to -1 that we're really close to 180 degrees on the unit circle. But we're still on the unit circle.